Hello, my name is Ammar Al-Zahri, and today I would like to explain the difference between a zero and first and second laws of thermodynamics. The first one is zeroth law of thermodynamics. We have the definition. Uh, we get from Dr. Tony Krisman. The definition is said if two objects are in thermal equilibrium with a third object, then they are in thermal equilibrium with each other by Dr. Krisman, which means that the two objects will be in thermal equilibrium. And the example for Zeroth law in thermodynamics we can see here, if we mix hot water and cold water, we can get the two equilibrium in just like one equilibrium. The heat will transfer from the hot object to the cold object, and the two equilibrium will be in a balanced temperature. And we have the first law of thermodynamics. Say the definition: energy is conserved in any process of a closed system. The energy increase or decrease by an amount equal to the net energy which crosses the system boundary. Actually, I think, which means that if the heat transferring to the system or into the system, if we this is our example in the life. I have it for piston cylinder. The heat is transferring to the system, and work is done to the system. And actually, we have the energy balance equation, which is the difference in kinetic energy plus the difference in potential energy plus the difference in enthalpy equals the heat transfer minus the work. We have here a question. It said 4 kilogram of a steam which is in a piston cylinder. If we applied pressure 1.5, also the work of the piston is 42 kilojoule. Find the heat transfer in kilojoule per kilogram. It said kinetic and potential energy are negligible, and we have our knowns. We said that M equals to 4 kilogram, and pressure is equals to 1.5 bar, and the work equals to 42 kilojoule. And we have our schematic. We have this is our piston cylinder, and we know the work of the piston cylinder and the mass and the pressure, and we need to find Q in kilojoule per kilogram. And we have our analysis. We can say that by using the balance equation, the difference in kinetic energy plus the difference in potential energy plus the difference in enthalpy equals to the heat transfer minus W. So we can negligate the potential energy and kinetic energy. So we will get the difference in enthalpy equals to heat transfer minus the work. And we can get the work by using the equation mass times pressure times V2 minus V1, and we can get the volume and the enthalpy by using the table A3 in SI unit. So we get for saturated liquid, V1 equals to 1.528 times 10 to negative 3 m cube per kilogram, and we have the saturated vapor for V2 equals to 1.59 meter cube per kilogram, and we have for enthalpy, which is for saturated liquid equals to 466.94 kilojoule per kilogram, and we have the saturated vapor for the enthalpy U2, which is equals to 2519.7 kilojoule per kilogram. And we can estimate our our energy balance equation, that the heat transfers equals to the mass times U2 minus U1 plus mass times pressure V2 minus V1, which is this for the work. And we can substitute our number that 4 kilogram times 2519.7 minus 466.94, which that it's in meter cube per kilogram, in kilojoule per kilogram, plus 4 kilogram times 1.5 bar times 1.59 minus 10528 times 10 to the negative 3 m cube per kilogram. We can get our Q in the heat transfer is equals to 8217.99 kilojoule per kilogram. And this is the find that we got. And finally, we have the second law of thermodynamics. The definition said the tendency that over time differences in temperature, pressure, and chemical potential reach equilibrium in an isolated system, which means that we could have some losses in some thermodynamics properties over time, such as entropy. And we have this is our example in real life, which is for the piston cylinder, and we can assume that we can have like some losses in entropy. We have here this is engine for the piston cylinder, and we have the valve intake valve, and we have a spark plug, and we have the exhaust valve, and the piston actually working to into the piston and into the cylinder, sorry. And if the piston push the fuel and the air mixture to the up, so the spark plug will burn the gas, and the heat will transfer from the piston cylinder to the exhaust valve, so that can make the engine works. And there will be losses in entropy. It depends on the thermal process, and we have the difference in entropy, which is if the difference in entropy bigger than 0, energy available for useful work increased, and if the difference in the entropy equals to 0, the energy available for useful work will be the same. And if we have the difference in the entropy less than 0, energy available for useful will decrease. And we can use our energy balance equation for the second law of thermodynamics. Thank you for listening, and I appreciate that. Thank you. My name is Ammar Al-Zahri, and I appreciate watching my video. Thank you.